I had lost my notes, but I hope you are still on. Let's continue. Now, I was taking you. We had finished this correction, and I was taking you to more examples that I had prepared for you today, and one of them is here. It says 12 grams. You don't have to write, because after the lesson I will send you the notes. 12 grams of potassium chlorate was carefully evaporated to dryness. Full stop. 2.4 grams of potassium chlorate crystals were left on the evaporating dish. What does this mean? 12 grams of potassium chlorate was carefully evaporated. Now, for it to be evaporated, it means to remove the water. So it means 12 grams of potassium chlorate, that was the mass of the solution. It was mass of potassium chlorate crystals and water. So you are evaporating the solution, which is potassium chlorate, and you are evaporating it to remove the water. So when it was evaporated, the question is telling you 2.4 grams of potassium chlorate crystals. Now these crystals do not contain water, remained. I want you to understand the question properly. 12 grams of potassium chlorate was carefully evaporated, meaning that 12 grams is the mass of the solution. It is the mass of the solution containing water and potassium chlorate. And when it was evaporated, you only remained with 2.4 grams of potassium chlorate. You only remained with 2.4 grams of potassium chlorate crystals. That is after removing the water, or after evaporating off the water. So the question is, calculate the solubility of potassium chlorate in grams per 100 grams of water at this temperature. So what you do, they have given you the mass of the solution, but they have not given you the mass of the solvent. When you are doing these calculations, remember you always begin with the mass of the solvent. You say this mass of water dissolves this mass of the solute. So apparently we have the mass of the solute, but we don't have the mass of the solvent. How do we get the mass of the solvent? Here, the trick that is here that wasn't in the first question is you first get the mass of the solution, which is 12.0 grams. Now this solution, it means it contains water, and you subtract the mass of the solute, the substance that was dissolved in the water, and you remain with the mass of the solvent. So in this case, the mass of the solvent is mass of the solution, which is 12.0 grams, minus mass of the solute alone. Mass of the solute alone is 2.4. Mass of the solute alone is 2.4. So it means that the mass of the solvent is 9.6 and the mass of the solute is 2.4. There we just proceed the normal way we have been doing our calculations. How? We say 9.6 grams of water, which is the solvent, dissolves 2.4 grams of potassium chlorate. In other books, you'll find when they are saying 9.6 grams is saturated by 2.4 grams of potassium chlorate. They mean the same thing. They mean the same thing. So what about 1 gram? 1 gram, you divide by 9.6 both sides here, and you also divide by 9.6 here. And that's how you have 1 gram equaling to 2.4 out of 9.6 grams of potassium chlorate. And 100, you multiply by 100 here, 100 here, and you end up getting the answer as 25 grams of water. 25 grams per 100 grams of water. So what should you take note of? This case, they have given you the mass of the whole solution. They have not given you the mass of the solvent. And you have to first get the mass of the solvent. When you are calculating, you say, in other words, you don't have the mass of water here. They have given you mass of potassium chlorate solution after it was dissolved in water. So to remain with the mass of water alone, you get mass of the solution, which is 12, and you subtract mass of the solute crystals, and that's how you get 9.6. I'm very sure that you have understood that. Example 2 that I have for you is also to be done in the same way. There is nothing that is going to change. 75 grams of a saturated solution. Take note this word of a saturated solution. So it means that the mass of the solute and water. To get a solution, you dissolve the solute in the solvent. If you get your sugar, a spoon of sugar, and you add it in water and you mix, now you have a solution containing water and sugar. So that's the solution we are talking about. If you want the mass of water alone, you will get the mass of the solution containing water and sugar, and you subtract the mass of sugar which you dissolve. Take note of that. So 75 grams of saturated solution contains 30 grams of a solute. So this is the solute that was dissolved to make this solution. I think that, yes, you should be understanding it. Calculate the solubility of the solute. In the same way we have done the first one, you are going to first get the mass of the solvent. There is someone writing on my screen. You are going to first get the mass of the solution and you subtract the mass of the solute. Mass of solution is here, 75 of a saturated solution, and you subtract 30 mass of the solute and you get 45. So this is the mass of the solvent, and you will say 45 grams of solvent is saturated by 30 grams of solute. What about 1 gram of solvent? We are dividing by 45 here, by 45 here. Then we get 30 out of 45. The other person who keeps saying 45 out of 30, please see what we are doing. To get 1 here, we have to divide by 45 by 45. That's how we end up getting 1. So to get 100 here, when there was 1, you multiply by 100 here and 100 here. And that's how it ends up. Just pure mathematics. And I end up having my answer as 66.67. Now this question is saying, calculate the percentage of solute in the saturated solution. This is 30 out of 75. This is the solute. divided by the mass of the solution, which is 75 times 100. Simple as that. That one, there is no magic. Factors that affect solubility of salts. We have amount of solvent. You know, if you have, let's say 2 centimeters cubed of water, and you add a spoon of sugar, and another person has a cup of water and adds a spoon of sugar, the one who has a cup of water, the sugar will dissolve faster than the one who has 2 centimeters cubed. So when the amount of solvent is high, then the solubility is also high, and vice versa. Then temperature. When the temperature is high, the higher the temperature, the higher the solubility. You know, if you have a cup of very hot water and another one has cold water, and you add equal amounts of sugar in those 2 cups, the one with hot water, the sugar will dissolve faster than one who has cold water. So that is the effect of temperature on solubility. The higher the temperature, the higher the solubility of the salt, and the lower the temperature, the lower the solubility of salt. That's what I had prepared for you today, together with corrections. I can now call upon you to ask questions such that